aspects of AI as a technology, how it can be used in the architectural profession as a concrete tool. And of course, the architectural profession has evolved over time, and the tools that are being used within this sector and field are of course developing alongside and also transforming the field. So in this session, we'll go more into the details of the architect's work, the practice of architecture, and the daily use of digital tools for building design. And of course, one of the things is, it's not only the very micro practices of an architect that is changing, it's actually also the entire field, the entire infrastructure, the organization. So we see more smaller architectural businesses now because we can have more, we don't need all the in-house specialists, but this of course also challenges the different specialized fields within architecture. So these are the kind of topics that we'll talk about today. And I hope that all my speakers for this session has returned from coffee break. So we have, and I would also like to invite my three speakers here that are here in person to the floor. We made a little bit of changes in the program. Unfortunately, we had a replacement of a speaker for later today, so someone is changing. But who we do have here with us at this session is Fillipo LODI, Head of Innovation and Knowledge Management on UNSTUDIO, that I would like to see here, and Josef MUSIL, Architect, Foster+Partners from the UK, and Pascal Terracol, Architect, D.P.L.G, full professor, doctor in geography, University Paris, Sorbonne. And let's do it like we did it in the last session, have a round of introductions to the topic that we'll discuss later in the session. And I'll start with having Fillipo LODI, Head of Innovation and Knowledge Management on UNSTUDIO, to present. Originally, just for the ones that are really looking at the program right now, Matias del CAMPO is still here with us, but he will join the next session. We changed a little bit in the program, but I'm sure that will work still.
Right. Good morning, everyone. I hope you had some good coffee. The one at home had some good coffee at home. Presentation is going to come up in a second.
Hello? Just to make sure that we get the right presentation, because we have a change in. So now we have Fillipo LODI.
Yeah, that's me. That's the pink one. So my name is Fillipo, and I'm a director at UNSTUDIO, where I lead a team called UNS Experience. It's a multidisciplinary team. It's an innovation and experience design lab. It's about around 30 people, different backgrounds, computer science, engineers, product designers, urban designers, strategists. All together, we are on a mission to create better experiences for the people and for the planet. That's kind of what we do. We are part of a UNSTUDIO. UNSTUDIO is an architectural practice globally present throughout the world. 8 different offices, Australia, U.S., Shanghai, Hong Kong, Dubai, so different parts, but headquarters is in Amsterdam, and that's where I'm based. And this is probably one of the most famous projects, which also shows a different take at it. This is a sailor that crosses the bridge every day when he comes back home, and he is so much intrigued by the bridge itself that he had tattooed it on the back of his body. And that is the stories that we create by doing design. They are really story that reflects on how people and their experiences are. Experiences transcend the spaces. The Mercedes-Benz Museum in Stuttgart, which has been realized in 2006, has a full program of activities. And of course, we link that program to to architecture, to its aesthetic, to the way it's made, and there is an intrinsic relationship for us to technology, the way we had seen that, the way we kind of basically programmed components of it to have control, to create efficiency. All that is part of the history of how we've been doing design over the last, let's say, 20 years. So this is 2006, so not 20 years ago, but almost, right? So considering we started 2003, yeah, it kind of dates back. And technology kind of, goes forward, right? So there is a lot of things in terms of control that we've been utilizing in the past years. So there's a lot of information modeling. There's a lot of test fit. There is a lot of using data to control. Lately, we've seen more a sort of immersiveness into things, so using technology to translate, so text to image, voice to image, image to voice. There's all sort of kind of mechanism of translation, mechanism of immersing, so you can collaborate digitally through the metaverse with other people. There is real-time imagery, so technology is evolving because the computation power of our machines, the possibility that we have to use technologies is changing. There is new form of seeing, camera visions, technologies get embedded into our reality, and people absorb that. The gentleman over here is called the famous most connected man in the world, right? He uses all sort of gadgets to connect. His toothbrush connects us to his smartphone connects it to his smartwatch. His gym program connects it to his the way he lives. The car connects to the watch, connects to the street. So all of a sudden, technology is much further pervasive, and it's all part of the built environment. So everything we do is part of that. And you know, in the kind of movie scenes that we see now, technology is fantasizing about, you know, how robotics will come and take space into our lives. And all this is just simply part of our built environment. And as architects, we design the built environment. We design with all this. Second, we know that urbanization is growing. Cities are much bigger than ever. And there is that lingering question of, what is the metaverse? What is the mesh? What is the future of everything that connects with each other? And as we kind of, as Marshall McLuhan famously said, so we build the tools and the tools are building us. And the difficult thing about that is that we are not, as human beings, we are not trained to think how technology develops. So technology develops much more exponentially. It's very easy to count 30 linear steps, but what are 30 exponential steps? Because technology changes exponentially, and that we cannot do. So then the question is for us as designers, how do we future-proof the future? So maybe linking to the first conversation we had earlier in the morning, so how do we foresee the future changing? And how do we capture that? How can we do that? So I brought with me 3 strategies and 2 stories that tell how we future-proof the future. The strategies are, well, first of all, we need to look into relationship technology. Where is the human and where is the machine? How do we relate with each other in all sort of fields? Human machines are more intriguing than ever, and we are specifically interested as designer in the place in the middle where the 2 things complement each other, where either humans are complemented by the machines or where the technology is augmenting humans because things that human could not do on their own. But it's very interesting where that happens. The second strategy is to kind of think at a broader systemic effect of the things that we do. So we don't design for human alone, we design for a broader shared value with each other, and that broader shared value needs to be kind of seen. The third strategy is, what is our role as designers? And that's where I'm always fighting every sort of discipline, in the sense that I believe very much to kind of take away the notion of the traditional disciplines and kind of work in an integrated way, in a multidisciplinary way, where that is the way we can create the future. So what are we as architects if not you know, the collage of a lot of different experiences and taking those experiences with us. So two examples of where we apply these strategies and what do we do with it. The first is an urban design, much based on a quadruple helix model, where we try to bring in different entities together to create win-win-win-win situations. It's an urban design in the Netherlands. It's a master plan called Brainpost-Maar District, 1,000 homes, of which we are at the moment prototyping 100. And the whole master plan has been designed with the notion of embedding technology into it, where the assumption is, could we create a place where every person that lives there does not have to pay rent or mortgage? So everybody that will live here will actually live because the built environment is paying on its own. So technology will help to do that. And what can you do if you don't have to pay rent or mortgage? Well, you can have more time for playing with children, for cultivating your garden, you can work less. And the technology that supports it is a layer technology. There's a lot of intelligence to connect. There's a lot of sort of data topics that we had to develop. We had to bring in. We had to bring in a data ethicist to understand the relationship with data and the ethics of how ownership of data is. So a lot of lessons learned to create this, and at the moment there are 100 homes that are being prototyped in this. So there's a lot of mechanisms to bring in the different use of technology, of materials, of constructions, and the intelligence that these will have once the building are realized, and they will keep on optimizing. They will be used to share information. So the solar panels, you can trade energy with your neighbors if you're on holiday, you're not using it, and that brings in forward. The second example, which is a very small scale, but deals with the relationship of human and technology, the same as the master plan does, in a very large scale. It's much more complex. It's a smaller scale, and it refers to stress. We see the kind of overpopulation of stress being a place. This is what they call the rage room in Moscow, and we created a reset. It's a series of pods that you can go inside, and you're measured brave wavelength and pulsations. This type of information is condensed into what we call the reset index, and every time that you go inside, the AI, the technology, the algorithm learns from the data of you going inside and kind of suggests a different way how you can distress yourself. And that's a product that we created. And so that brings us to the question, so how do we future the future? Well, how do we do that? And how do we put that in practice? Well, we believe much in seeing the fact that kind of the world of technology, society, economy, they're all kind of changing together, and how can the design, what is the design line that connects into it, and you know, what is the architect line in it? And so how can we bring in different a notion for our future? And we believe much in not confining ourselves to the smart, to the convenience, but to use technology to embrace to embrace different questions, and the questions that are more about the nature of value that we can create for the users and the planet that we live in, and to bring that level of notion into our design. Thank you so much.
Thank you, Fillipo. So, yes, please, Josef, MUSIL.
Hello, everyone. Okay, so my name is Josef. I'm going to be talking about AI for environmental design at Foster+Partners. I work for Foster+Partners in a small R&D group called Specialist Modeling Group. And so this is one of our older buildings in London. It's fairly known, but it was one of the first buildings that was designed in a way that was considering the link between the outdoor airflow and the indoor airflow. So putting window openings in specific locations and seeing when you open them, what happens on the inside to create a healthy environment. Now, to do that, you need to do lots of, you want to do lots of simulations to actually understand, because especially wind flow is a fairly complex phenomenon. So on the left side, you see you're going to start doing analysis of the outside. It's called CFD. And then with combination of tools, you can analyze when you open certain windows, what actually happens on the inside. Now, why would you want to do that? So you can design spaces for certain ranges of wind speeds, and these wind speeds directly have impact on what people are going to enjoy doing there. So you can design spaces for standing, sitting, strolling, walking, or you can make the spaces actually very uncomfortable if you don't design it well. So in this way, you can directly promote healthy lifestyle by, telling people, well, providing spaces where people can go outside and enjoy the time outside. And the same applies to indoor spaces, but unfortunately, the idea of modern building today is not far away from building a submarine in air. So it's tightly sealed, the air is coming from somewhere far away from the building, it goes through meters of pipes, there might be clean or not, and actually at the same time you have the fresh air just a few centimeters away from you, just behind the facade. So if you could open it and get it inside, you might provide healthier environment, and also the buildings consume 40% of the world's energy. So if we can work more with the idea of passive solutions like natural ventilation, then we can improve, hopefully, the built environment. Another reason to do that is that humans are not necessarily designed for like a steady environment. So humans were designed to be in a dynamic environment. So if you look at the image on the left, that's a typical picture of a park. Maybe you have a little table there, and you see there's a high range of colors, high range of temperatures, different areas of different temperatures, a bit of airflow. On the right side is like a typical office space. It's all very neutral. There is this idea that everything has to be constant temperature, constant lighting, but actually it's not what humans enjoy. One of the reasons is that it engages the brain in different ways. So dynamic environments engage brain through multiple senses and create a more enjoyable environment. The right side, you can see the thermoneutrality engages very little the brain, and it gets boring and not enjoyable. So now if you look at specifically at passive solution for airflow, you might argue, well, it's not always possible to open windows, but if you look at the map, you can see if you allow for some sort of range of temperatures or a range of airflows, most parts of the world will allow you to do the passive solution. In terms of analysis, we have a whole range of tools that are able to help us to design that, and they vary in terms of complexity and time. So, and the main problem is the more rough estimates you get, the faster it runs, and the more complex simulations you do, the more time it takes, and the most detailed simulation, they can take up to weeks, which is a big problem, because when you design a building and you are in a concept stage, where you really focus on massive changes, you can't do, the later in the project, you can't do changes of the overall shape, for example. That is just not unthinkable. So you need to do, at the very beginning, a lot of very fast simulation to allow you to do big design changes. So AI, in this sense, provides an opportunity to do prediction of certain simulations with accurate enough that's useful for the design stage, but run almost in real time. So this is one example of how we used, so we built in-house a little AI model that predicts the airflow. This is, for example, a master plan for a tropical island. And the idea here is to play with the buildings in a way that you provide just enough airflow in between the buildings to support the idea of cooling. So it's not too much, so it's not comfortable, but it's enough so you have a bit of a breeze and it feels good. Another example, this is the opposite, when there is too much airflow on the outside. So this is in Shanghai, project in Shanghai. And we wanted to design the blocks in a way that they are open. We don't want to create like a solid wall to stop the wind coming in, but we want to protect the inside courtyard. So it's a healthy place, you know, to be there. You can go for the run, picnic. So you have just the right amount of airflow coming through. Another visualization, the interesting things we can generate, we can predict data in a format that we can plug directly into engineering software with the AI, because it's up to us to decide how what sort of data we predict. And it allows us to use standardized tools to visualize that, help us to communicate the design. So now what we have is this traditional workflow is you have a simulation, you get a report, you influence the design. The problem is, as I said before, it might take anywhere up to 1 to 3 weeks, which is just too slow for concept stage. And the second big problem is, even if you have the best report in the world, typically it doesn't tell you how to influence the design. It tells you this doesn't work or this does work, but it's up to the human to use the report in a meaningful way to actually make changes to design to improve it. So we're proposing, can we use AI to help us with both? So it's something I call forward direction. I will show you, we build a model that can predict the simulation in almost near real time. But then we also look at, can we actually reverse? Because AI allows us to make unusual connections. So can we train it in the reverse direction? Can we start with the simulation and ask AI to predict the buildings, where to put them to achieve such a simulation? So this is a graphic representation of a circular workflow. On the top row, you see this is the forward direction. You take a few buildings, and you use AI to predict the simulation. And then you use the manipulated simulation directly, and you ask AI to predict where to put the buildings. The good thing is, with all these parametric models we have today, we can easily generate whatever training set we need. And you end up with a nice circular workflow where the architect works directly on both, on the design of the building, but also on the effects of the building. And you use, in a circular way, the AI to influence both aspects. And this is our, so we implemented it in typical architect's tool, Rhino Grasshopper. So it's fully interactive. You can build your models and see in real-time simulation. The interesting bit about, if you have simulations or anything that suddenly runs in real time, and you spend some time with it, it gives you a little bit of intuition how the design changes influence the analysis, for example, and gives you a bit of better understanding of your design. It's all run in 3D. That's important because obviously, for example, the wind flow is a 3-dimensional problem. And this is the moment when you go into the reverse direction. So you put a threshold on the wind analysis, because it's not meaningful to directly manipulate CFD analysis. But what you can do is you can say, these red areas, these are the zones, let's say, under certain speed that are suitable for running or park. And what you want to do, you want to design these spaces directly. So you start manipulating it, and you ask AI, where do I put buildings to achieve such effect? And then, because you can directly go straight into the other direction, evaluate if the simulation is doing what you are asking for. In the future, the interesting bit of AI, when you open the box, you can start incorporating your custom functions, like physics-based function, to make it much more precise. We would like to implement it in some sort of Gantt style, so the analysis gives us different solutions to the design. But really the bigger picture here is, can we spend less time designing buildings, and can we spend more time designing the effects of the buildings they have on people? Because that's how people really perceive buildings. It's through the light levels, it's through the temperatures, it's through the airflow, sunlight, etc. And hopefully AI will allow us to make buildings more performing better, but also healthier and happier places.
Thank you. And so we have the last speaker for now, and then we'll have the debate. Pascal, Terracol.
Hello, all of you. Thank you for the invitation. A few words about my background. I'm coming from a software developer, and I've been an actor for putting on the market of one of the first 3D synthetism model in the late 80s. And now I am in charge of a master of a master which is based on we are operating a chair architecture and intelligence in Paris, in fact, and we have already trained, let's say, something like 50 students on a prospective way on a subject from 2017, in fact. So, what I would like to present you is the question was, what about the deal between the tools which are pricing with AI and architecture professional? And it's not so easy because professionals have a site of those tools, and there is a disruption, a kind of disruption of those tools, in fact. But we are on the go, and let's say, we have to displace a kind of automorphism of the architect, and we have to train them. And we're going to go to open a professional master on that tools. And we invite ACA and maybe other actors to join us in Paris for that subject, because it's a real goal, in fact, to provide the knowledge of those tools to the professional of specialization who are the architect, in fact. So this is a real invitation, and maybe UNSTUDIO and maybe Foster, you are well, we can work together. That's it. Let's say, what is the value of architect? So it is a real subject, because the question is evolve, and we cannot let this space open to only, let's say, economics actors or marketing actors, in fact. And they are not so far from that, and we are working to open this kind of tools to the architecture fields, in fact. That's it. And a big question, is we have in French something like DTU, which has sheets, technical sheets, in fact, to regulate the way to construct and to design a building. And maybe this material could be fit in neural networks to provide a graphic action made by architects and to make alerts from them. And this is maybe in a prospective way we are waiting for these kinds of tools. And it is a real situation, and it is we are dreaming of these tools. And I think we're not so far, because we have CSTB in France, and they are managing this material, and it's a big question, in fact. So we are in the situation in the last months. We have the fact is several tools are pricing, and let's say we have speech to text, which are already online, and we have let's say, I made for myself. I've published my course, which is a analytic geometry course, because the parametric modeling tools are already here, and it is impossible to let the student outside this field, in fact. And now, with a simple prompt, I made a survey of my students on the question: do they know parametric? Do they know what is a ruled surface? What is HP? A parabolic, hyperbolic surface, and so on. And I made not so far the same question to the tools which are here with a prompted rule. And for the situation is, for now, that students are better than the neural networks. But it is the situation is going to evaluate, because neural networks are learning too, and we are providing the knowledge to them. So. And let's say there are several tools. It is really, there was a few weeks ago, these tools were not there, and we are in a prospective way dealing with this situation with our students. And text-to-image exists. So the constat is Delhi, for example, knows about Le Corbusier. So it's a constat, in fact. and DALI, for example, but maybe also stable diffusion and so on, knows about modern architecture. This is an example. And the very last announced tools which has been raised is we were speaking with our student about we're not going so fast to wait for, let's say, a text-to-model tools, and NVIDIA has provided, in fact. And with a simple prompt, you have a mesh, and this is incredible. In fact, it has to be tested, but it has been invited. And the question is, if we can write something to design an architectural feature. Let's say those aesthetic is going to be disrupted by semantic. And this is a big question because in the stakeholders, the architects are very well fitted with the vocabulary of semantics because they know about architectonics. And let's say other stakeholder, maybe engineer doesn't know as well this kind of feature, in fact. And the question is, does, let's say, the question is, do we have to design something, or do we have to write or to enhance a project now? This is a feature, in fact. And this is an example. The row shows the opera of Sydney. So we have to test that, but this is announced. And so the semantic is a very big tool to get hands on this AI tool, in fact. So, for instance, we are working. Let's see, we have. I'm directing three theses, and we are in a disposal, which is a French one, which is a contrat CIFRE, which is a triangle between academics, industrial, and university. And we have one of our students, which is this company, which is a society, Association AQC pour la qualité de la construction. And they have, let's say, something like 25,000 data sheets on sinistrality, in fact. And this material can provide fitted in a, we'll see what is going to be the result of the thesis. But this material, data material, is a really specific one to enhance the knowledge by sinistrality and to provide something like prediction of what is going to be suitable to design something or not, in fact. So, and we have also we have built also a lab which is a data-driven to make urban analysis, and this is done by open library and open tools, in fact. And it is already working, and we are training our students on that on that. Tools on that process. And the question is, here we are on Paris with data.fr, which is an open data provided by the city. And the question is, what is the capability to enhance the height of the building? Yes, okay, I finished. So this is a survey of the three theses. We have one. This is AQC, the first one. The second is based on the air park and the way to build, let's say, HTOL, VTOL and HTOL, which is a situation to make links between hyperdensity and rural, in fact. I understand. I just present these three views, and this is a question about les nouvelles mobilités aériennes with avion Mauboussin, and the question is how to provide a service near upper density, and this is a question of air park exactly. I think it is the end of my presentation. So the fact is, urban analyses are already on the go. We are going to open a professional master, and we're going to enhance the knowledge on a prospective way on that subject. Thank you.
Thank you. So we've had really presentations of a wealth of different ways of using AI very concretely in the architect's work, and also some academic reflections, and interesting to see also how students can be involved in this. So I was thinking that what I think would be the most interesting thing to try to do throughout these sessions is to start off by asking you about the opportunities of AI. So starting with the more positive note, understanding, so what do you see if you have to gather, with all your wealth of knowledge and all the practical applications you've been presenting, what do you see as the biggest opportunities of AI right now for the architectural sector and profession? Let's start from...
Thank you. The opportunity is pedagogy and research, and we are on that track. I answer the opportunities. Our goal is pedagogy, research, and to train professional on that open state and landscape of tools. In fact, that's it.
Yes.
The opportunity that we see is that technology can enable us to create better lives, right? So we can design spaces where people have more time to do other things, because technology is taking care of some of our some other aspects of what we couldn't do before. So how can we enhance the quality of life and the quality of the environment that we design for?
Yeah, similar like what I presented. I think the opportunity is to design directly for things that are traditional as a result of our architecture. Like the thing, how you perceive buildings is sort of like, it's a result of a design process, but you don't design necessarily that. So we can flip that. We can really look at how people feel in the buildings, which is generally so complex to even start analyzing. But maybe with the computational tools and AI, we can actually directly manipulate these things. And I think also generally, like, we have this, like, every year we get a new computer in the office, which is much powerful. And we always hope we're gonna get things done fast and we're gonna go home sooner. But what we end up doing, we just end up doing more work because we realize we thought we only wanted to have 3 options, but the reason we did only 3 options was that we couldn't do more of them. So the opportunity is to incorporate much more data that is related to the users of the buildings, which we didn't think we could before. Yeah.
So I mean, listening to all of you, what I see kind of on the top of it as something that seems to be really helpful in the architectural sector is this idea of making sense of a lot of complexity. So complex environments, complex spaces, and also making processes more efficient. But at the same time, I think that, I mean, when I look at this room, for example, it's a wealth of complex, not only information, but human factors and human being in environment. There's air, there's faces, there's memories, there's cultures. Is there, and now I'm moving from the opportunities, is there like, how do we ensure, and we talked about balances earlier, how do we ensure that these very good ways of standardizing the architectural profession and the methods that you're using, how do we make a healthy balance in this?
I would say we're hopefully not going to standardize anymore. We're going to be more accustomed to, all the people inside. So it's going to be more dynamic environments, more customizable, because I'm sure today design are biased towards certain group of people anyway, and that's the standards are. So hopefully we're going to go away from standardization and go more for customization.
Can I add something to my question? Because then, I mean, an AI system, an AI tool is very much designing right now for the mainstream. That's what I hear from my profession, working with the ethics of AI and also data ethics. What is happening is very much a design for the mainstream, the standard. And so in many of these kind of cases, when we're thinking about we're designing for people and cultures, we might reduce it to a mainstream. So I'll let someone else answer also, but I can see you would really like to answer that question also. So.
Yeah, if I can add something to the topic. So if we see it, sort of technology in a positive way, in a sense where it allows us to do things that we couldn't do before, the biggest threat to it is our own knowledge of that technology. So we need to create more literacy of the technology itself, of what is under the hood of the technology, to kind of be sort of aware of the biases, be aware of the ethics, be aware of that. So in fact, what we are doing today, by just talking about it, it is actually the right thing to do, because we need to kind of know more. So we need more masters in data literacy for all the architects, so to enable us to kind of to use that as a tool, and to do not make sure that that tool makes us again, and that is the scary part. So if we can, and then that's the only way we can create a sort of a balance.
I agree with that, Philippe. Architects are in an open epistemology scheme, in fact, and it is a real quality. And I think that sinistrated data, as I mentioned, has to be fitted in a BIM object, in fact. And this is a real situation and a real service to be provided to the architect and to the society as well.
So that is, I mean, very concrete ideas on you know how we can actually incorporate these more ethical, maybe social considerations. And then if we think about one thing also that is general, and this is not only for the architectural sector, this is this idea of AI and the implications for the workforce in specific sectors. How do you see this? And also based on your experience from working in the field for many years, do you see any challenges, any opportunities that are, you know, in terms of the workforce and the employment in the field?
There is a real challenge between the gap and the deal between technology, data, and public space. And this is quite a politics subject, in fact. And in an open mind and with an open tools situation, in fact. And we are getting with nos élus en français, je ne sais pas comment on dit en anglais, our policies are major, in fact, and in little town, and this is a good way to enhance the quality of designing public space and so on.
I got my own one now.
I'm just going to say I think we need to involve new professions in architectural offices. I think we need to, at the moment there's a bit of an issue to get enough interest of the highly intelligent people in other domains, which architecture is not necessarily seen as the dream field. So I think we need to reach out to those domains and, you know, show them that we have super interesting, super important problems to solve. So we attract the new, you know, sociology, computer science. Computer science is probably quite common today, but let's say AI, you know, the most intelligent students, they don't necessarily see architecture as the dream where they want to go. So I think we need to change that. And I'm sure we have, it's just they not are aware that we have super interesting and important problems to solve.
The opportunity there is to reflect on the profession of the architect in itself. So who's an architect? And well, that might not be the same architect as Le Corbusier was. That's the future of the profession is not the same. Although we still design, but there is an opportunity to take in different disciplines, such as so the kind of computer science, the technology, the sociology. So we can bring in different expertise to the value of this profession, which is mostly a sort of a generalist The architect traditionally is somebody that coordinates all different things. So how can we rethink the profession to make it more valuable and therefore then attract the right talent? How can we reposition this in the field of the things that we do? Can we make it relevant for it? Otherwise, then we don't attract the right talent, the right people, and the quality of our built environment decreases. Right? There's all sort of there's a down spiral to it if we don't do the right job as professionals ourselves.
I can add something. There is an item which is really important. It is nature, and we are working also in the process of recycling material and so on. And this is a real goal to values, let's say, environmental and sanitary aspect for society. So, and we have the tools to do that and to go on that track.
So let me open to the floor and see if there's any burning. I see a few hand, one there and one there. So I think you were first, the gentleman here.
Thank you very much for the amazing presentations. I really enjoyed them very, very much. I have a couple of comments or questions for you regarding maybe a common language understanding of how to talk about AI and architecture. Maybe we can, I hope we can agree that one of the major paradigmatic shifts that are happening right now is a change from expert systems to learning systems. And considering that, it means that we're moving away from something of a top-down, let's say, parametric modeling method, which basically specifies what you want to have as a result, and rather interrogate large data sets to understand problems that we want to solve in one way or the other. Now, in the presentations we saw, the vast majority was actually parametric modeling that we saw here. And I have to admit that I have a hard time with a presentation that says AI does this, AI does that, without giving details like which algorithm was used, which data set was used, because those are the things that inform us as a community more than just saying that the AI did this or that. The other thing I want to comment is that AI is just an umbrella term, right? I mean, it's something that covers a vast area of different machine learning methods, algorithms, et cetera, and I would appreciate more specificity with this sort of information.
So that's a very good question regarding getting more, into the details of, and probably also will be practical in terms of when you're sitting as an architect, what kind of tools, which kind of services are you using, and then what kind of models. I see you. You seem very ready to answer.
Yeah, I can reply to that. I think there is in what I was referring with sort of the literacy of the technology. That's really where the notion stands behind how we communicate the things that we communicate. So often there is a lot of lack of knowledge of the technology that is behind the things that we show, and that literacy is very it's required to have a discussion of that level, as if we would talk about the sort of data lake that we're using to get information cross platforms, where the smart city project that we're using, how did we build the data platform on it, which a cloud provider we're using, what is the choice of the cloud provider. So there is a lot of knowledge behind that, and that's really the one that we should have time to dig into and really talk about. And in order to equalize the conversations about it, then we need to bring more specificity to the wider audience of the architectural industry to just even have a conversation.
First, there is also two subjects. First, there is the Digital Act, which is on the go, in fact. So you have to be aware of that. And also, there is these tools are not on the go, but they are not so far. I think, in a simple gesture, a graphic gesture done by an architect within a software, we would like to have an alert saying, "Beware, you're getting out the juridic or technical specification," in fact. And this has to be done, in fact. And the assumption of this assertion is to have a good quality of reuse, recycling, the respect of the regulation and the impact with environment too as well. So this is a prospective site.
Joseph.
I'll just agree. I would actually be against ourselves if we don't talk clearly about what we're doing, because it hides the opportunities and creates some misunderstanding. So we should be more clear about that. I want to make my note on the difference with the learning algorithms. I think there's going to be something that probably designers will need to get used to, because the tools presented, we keep thinking that it's going to be something that keeps learning as the office evolves, which is something completely new in design. You're used to that. You have a tool, and half a year later, it's going to do exactly the same thing. But with these tools, there is a good chance, half a year later, they're going to be giving different results. So I think something we need to get used to. I don't know what the implications are going to be, but I know it's going to be something. You're going to lose a bit of the guarantee what it does. It's going to be more opportunities, and we need to find ways to work with that.
Yeah, it's very important in general to understand the granularity of the use of AI, because if we want the AI to be empowering, then we also have to understand, the tools that they're first of all, they're not available to all, and they're very different forms, and they're definitely not neutral tools, all of them. And then there's the literacies involved in this, so that's a very important point. There was a question here.
Yes, thank you. I have a question to Fillipo Lodi. You brought a slide that was one of the more interesting ones today. It was 3 columns. We had humans on the left side, and machine, and then in the middle the merger between humans and machine. Unfortunately, it was too quick. So could you maybe make a recap on it? Because I think it gives us what are the potential of the humans, what are the potential of the machines, and then what is the potential of merging it, what we are talking about.
So the perspective comes from the fact that on one end, we know what we can do as human in terms of the process that we have in decision making, in designing, in collaborating, and we know what the machines can do, which is the parametric component. You give something the machine does, but you have no interaction with that unless, well, of course, you program that or somebody has programmed that, so that stands alone. And the effective intelligence for us is when we can create an interaction between that. So either by having the machine support us in doing things that we don't need to actually do, and kind of optimize, speed us up in the way, or really create sort of an augmentation of the things that we could possibly not do, because we cannot think exponentially. We cannot have in seconds result from Watson, right? We are not Watson, so we cannot. We can augment what we do, the decision that we take as a human being, because of that. And if we work very hard on that intersection where the two things are there together, I think that's where we can create a far more interesting result.
Yeah, and then the interesting question for me is, on the human side, you had the verb judge. So humans are good in judging. We all agree, right? Preparing this conference, we were joking about, would it be possible you have an architectural competition, you have judges, and you have one AI judge? What do you think would have to happen that AI judges would be possible? Or did you ever work on this?
Yeah, I think that's a tricky question, but it would, if I, thinking out loud is reflecting on what the first speaker of today talked about. If the data that is used to judge is trained on the past, then how can we judge things of the future? That would be the main question to do that. And so far, that's the difficult relationship yet to create. So from our stand, so far, the far more interesting one is if we combine the human and machine, then we can create something. We can look at the future in a different way. by kind of speculating on things that do not exist, right? And by not just looking at the sort of data set, which is somehow an existence of the past, but if you could use it to kind of generate things on which they don't exist. And there are all sort of loop there, but they're also always starting from an existing data set, which is the conundrum of the whole assumption so far.
I would like to recall about your question on human, the three major paradigms of AI, which are classification, regression, and human supervision. And the last one is maybe the most important, because all we are listening, we are training the neural networks, in fact. And maybe maybe it's we don't realize these kind of things, but already with Google and so on, and with the tools we have on other subjects, but fitted in the architecture fields, there is a global knowledge which is uprising, and it is the society and human components from this way is a really important one.
So I can add two kind of interesting, I don't know if you could call it facts to this. Actually, someone did make an AI judge for a competition. There's a very famous case of an AI judge for a beauty contest. And it turned out, of course, when this, people had to send in from all over the world pictures, and this AI judge was then applied. Of course, it was just a piece of software. It wasn't really a robot or anything. Was to decide which face was the most kind of objectively most humanly beautiful one. And then when it came out, it turned out, of course, that it was incredibly biased. It only chose white faces, and wonder why. It was because it was mostly trained by pictures of white people. So in that sense, you can see that an AI judge, I think the learning thing from this is that an AI judge to judge something so humanly kind of unique and characteristic would only be able to reproduce what humans already can do. Another part that I find really important to frame this debate is the kind of the geopolitics and the regulations that are being created around AI at the moment. There is the idea that the EU is creating a kind of human-centric approach to AI in terms of governance. So there's a lot of regulations and also the AI Act that has this focus on creating governance structures and also use of data and creating data systems that are, and AI systems that have this component of having the human, and it's not very like the human in the loop, but the human in command. So via different both technical but also social and organizational aspects. So that's a really important point to kind of make, saying that we're in Brussels right now.
It's interesting to think that I don't think just having a human in it doesn't necessarily mean it's not biased, doesn't it?
No, and just to that we have an AI neither. So we have to find some combination that in some way will ensure that, not ensure because everything is biased, even an AI system is biased in the way that it always believes that the system is complete.
Maybe in a way the AI might help us to understand that what we think is unbiased is actually biased by showing that, if you try to repeat the result, it's going to tend to have some bias on it.
Could be.
I would like to add something. We spoke about human supervision, but we can add software supervision. With a simple line of code with Pythons, you can put a server not so far from a denial of services. And as I mentioned, from text, the link between text, semantics, aesthetic, and maybe ethics, we have to be aware with this kind of thing, because with a simple lines, the power of a processor and maybe a few processors, you can influence the data knowledge and maybe put aesthetics outside and to disturb it, and maybe ethics. And this is a political subject, in fact. Also.
Yes, and technological and social. I was wondering if there's any questions from our online participants here. No, there's no questions. Well, so we have any questions from the floor? No. So let's, we have a few minutes left, and I'm wondering, so how do, so AI architects or the architects that are using AI, so how do, on general terms, or not only architects in general, not only architects using AI or professionals working with AI, how is this perceived in the field in general, the uptake of AI technologies?
Not so easy. There is, let's say, in France we're coming from Beaux-Arts, mood and so on. And this subject, we are a few schools in France to train our students, but we are on the go and we are working on so we are on a paradigm of displacement of pedagogic models, in fact. So.
Josef?
Well, I can see there is a direct relationship between the level of understanding of it and the level of excitement about it. So I think the more you understand it, the more you get excited. That's what's happening, at least in our office. So there's lots of interest, and there is a bit of a fear, but it tends to realize there's people who don't actually have no idea how that works. So I think it needs to be more literacy and just, it's a tool. There is a potential risk. We should keep it in mind, but not to be clear about that.
But okay, come on, Philippe.
It's also, if we refer about AI, on one end is the sort of the technology that we use as a part of the process that the architect does to do the architecture. And on the other hand is the technology embedded in the spaces or in the built environment that we live in. So it's two different worlds. One is more what some architects might be really super energized by the topic, and they have passion about it, but they would require more knowledge to do it. And on the other hand is sort of the application of this field that as designer we can apply to the built environment to really capture a different results, right? If we embed a full city with sensors and we can get informations of all sort of things that are connecting to us, then it's less about us designing, using that as a design tool, as a process for us as professionals, but it's rather what are the implications of that technology in the places that we design because that technology is inserted into it. And the second one, I find that far more interesting than the first one.
Can I ask quickly, and maybe also you can
Yes,
answer that
yes.
question.
Okay.
So if you're an architect, and this is the very last question because then we are off to lunch. If you're an architect that really would like to use some of these opportunities, very concretely advice, what would be your advice, people that are really working with this and using the opportunities?
Invite professional in our session in our master. We were yesterday with the French Ministry of Culture in a seminary based on the chair. And this is a question, the loop between pedagogic skills, research, and practical. And so the professional is really important. And we are going to open this kind of training to the professional we are invited. Maybe at Europe scale, welcome.
So attend open courses that can help you. So that's a very good advice. Fillipo?
Start a startup or do something in it that requires that technology to be bringing it forward in a different way. So kind of be a bit more radical into it.
Yeah, it's like to start learning about it. There's so much for free today online that you can just start being learning these courses online and reach out to specialists, learn about it really.
Okay, so those are all good advice, and then I would also suggest that if you want to embark on using AI, of course there's also the sites that we've been the components of being aware of the social impacts and the ethical impacts and these things. So there's actually a very good guideline for using AI in your work. It's called the LODI guideline, one that the high-level group for an AI, the EU high-level group created, that we created. An assessment list with questions you can ask yourself when you're using AI to see if you're keeping an eye on also this human relation. So I just want to say thank you to the three of you. Amazing presentations, very interesting conversation, and now we're ready for lunch. We will be back at 13:30, and the lunch break is where?